Guys, Mr. Sonnenberg here. Today we're going to be talking about chemical change. So basically what we have to know with chemical change, we're also going to talk about chemical properties. So whenever you see a chemical property, you're going to talk about how the substance reacts with another. So basically, if you see the words, say if you were to identify it from a list, you want to know the difference between chemical and physical properties. Well, chemical would be the ones that say reacts with, or they're combustible, or reacts with air, reacts with oxygen, reacts with water, or reacts with acids. So in this example, basically what I have is I have a nail. Now we have different types of nails. Um, Regular spikes, for example, when you're building a house on interior walls, you use regular spikes. Okay, but then there's other types of nails as well that they have a coating on them, and then they're good for outdoor, so that they don't rust when they're exposed to air and moisture. Because what's happened with this nail is it's actually rusted. Okay. Also, if you take a penny and you put it in water, then what's going to happen is it's going to change color and it'll turn green. I don't know if anyone's ever seen that, but that actually occurs as well. Okay. So chemical properties, though, it becomes evident when you can tell a change is occurring. So if you look at this Alka-Seltzer, when it's dropped in water, it starts to bubble or fizz. The bubble and fizzing is actually a gas being given off. So what's happening to the Alka-Seltzer is it's changing in composition. It's getting smaller, and now now it's giving off a gas, it's losing its molecular shape and such. Okay. So there's four main indicators of chemical change. One is a distinct color. So the statue in this picture used to be a brownie color and now it's green. So it obviously reacted and there was a distinct change in color, so we can identify that as a chemical change. The second thing is that there's going to be a release of energy. And that's usually going to occur in either a form of light or in a form of heat. So the fire is giving off heat and light. Stand near a fire, you warm up. Okay, fire goes out, gets pretty cold. Okay, fireworks also, they're going to give off heat, but they also give off light, and they give off different colors. And there's a reference to those different colors in the metals, non-metals, and metalloid screencast as well. But if it gives off energy in the form of light or heat, we can tell chemical change is occurring. So if I took a Ziploc bag, for example, and I put some chemicals in and the bag got hot, kind of like hot packs, cold packs, like hot packs when you want to keep your hands warm. Firefighters use them a lot. Also sometimes, you can put them in your skates if you're skating outdoors to stay warm. Okay, and that's a chemical reaction occurring, and it gives off heat. So there's a chemical change occurring within that packet. The third thing is there's a formation of gas or solid precipitate. So as we looked at the Alka-Seltzer, there was bubbles giving off a gas. So anytime there's bubbling, or if, say, a bag, Ziploc bag, for example, filled and inflated, and it bulged out, well, that means there's gas in there. Okay, solid precipitate's basically referring to something clumping. Okay, so in this picture, it shows the substance actually balling up and clumping. It's almost like curdling. It looks like, right, when milk curdles. Okay, and that's called a solid precipitate. So the fourth thing is there's a noticeable change in the smell. So if you burn paper, you're going to recognize that there's a smell. Change in smell refers to a chemical change. Also, you burn, say, a tire or something like that, you can smell it. It stinks, and there's a chemical change occurring. And then last, I just have kind of an example of chemical change. So if you were to take metallic magnesium and you add it to an acid solution, what's going to happen is you're going to see bubbling, and the bubbling is the formation of gas. And you're also going to see, secondly, that there's energy given off, and that energy is going to be in the form of heat. So the container will get warm. Okay, so if we were to put a thermometer in there, you would see an increase in the temperature of the thermometer. And that is outlining and identifying chemical change. So what I have at the end here, though, is I have a little video. It's about 3 minutes long. And basically what the video is just paper on fire, but it's been produced by somebody. And what I want you to think about while you watch that, though, is when the paper is lit on fire, is the paper that's burned, can it be reversed? Can it go back to the normal paper it was? No. Also, does the paper give off light or heat? Of course it does. It's fire. Okay, it creates a flame. Would that paper smell? You can't smell it through your computer, but you can imagine what the burning paper would smell like. Okay, so are there different changes that are occurring? Okay, so watch the video, and I'm going to conclude the screencast here. Make sure you watch the whole video as well. and there'll be some questions to follow. Okay, thanks guys. Bye.